Hello and welcome back to the Master Civil Engineering, and in this video you will learn that how to plot the Mohr circle in Excel for the results of consolidated undrained triaxial test and also find the shear strength parameters of the soil. So let us start the solution video. I have been given the results of consolidated undrained triaxial test on undisturbed soils retrieved from 8-meter thick saturated clay layer in the field, for which the saturated unit weight is 19 kilopascal. We have to estimate graphically the Mohr Coulomb shear strength parameters, that is the C prime and phi prime, and also we have to find the shear strength in the middle of the clay layer. So let us find the solution. First we will draw the table for the test results in which the chamber pressure, deviator stress and pore pressure are already given in the question. We have to find the major and minor effective principal stress. For test first, effective minor principal stress, that is sigma 3 prime, is given as chamber pressure, which is sigma 3, minus the pore pressure at failure. So for test first, it will be 100 minus 15, which is 100 plus 15, which is 115 kilopascal. For test 2, it will be 200 minus 40, so it will be 240 kilopascal. For test 3, it will be 300 plus 80, which is 380 kilopascal. Effective major principal stress is equal to effective minor principal stress, which is sigma 3 prime, plus the deviator stress. So for test first, it will be 115 plus 170, which is 285 kilopascal. For test 2, it will be 240 plus 260, which is 500 kilopascal, and for test 3 it will be 380 plus 360, which is 740 kilopascal. After finding out the major and minor effective principal stress, we will use the Excel to plot the Mohr circle and find the shear strength parameters of the soil. So let's move to the Excel to plot the Mohr circle. To plot the Mohr circle, first we will find the radius of the circle and average stress for each of the tests. You can see I have already made 3 tables in which the effective major and minor principal stress are already written, which we calculated earlier. Now we have to find the radius and the average stress for each of the tests. So radius for each test is given as the sigma 1 prime minus sigma 3 prime divided by 2, and average stress is given as sigma 1 prime plus sigma 3 prime divided by 2. To find the radius of the first test, you will select this box and then click equal sign. Then you will write down the bracket and select the effective major principal stress for the first test, which is 285. And then you will write the minus sign, and then you will select the effective minor principal stress for the test first, which is 115. Then close the bracket, divide it by 2 and press enter, and you will get the radius for the first test. To get the average stress, you will select this row and then again write the equal sign, write down the bracket, select the sigma 1 prime for the test first, then write plus sign, and then select sigma 3 prime for the first test, then close the bracket, divide it by 2 and then press enter, and you will get the sigma average for the test first. Similarly for test 2, to find the radius, select the row, write down the equal sign, then bracket, select sigma 1 prime, then minus sign, select sigma 3 prime, close down the bracket and divide it by 2 to get the radius for the test 2. And similarly for sigma average for test 2, you will write equal sign, then bracket, select the sigma 1 prime, then plus sign, then you will select the sigma 3 prime, close down the bracket, divide it by 2 and press enter, and you will get the sigma average for the test 2. For test 3, apply the same procedure, select the row, write the equal sign, then write down the bracket, select sigma 1 prime for test 3, then minus sign, then sigma 3 prime for the test 3, then close the bracket, divide it by 2 and press enter, and you will get the radius for the test 3. Then you have to find the sigma average for test 3, write equal sign, then bracket, then select the sigma 1 prime for the test third, then plus sign, then select sigma 3 prime for test 3, then close the bracket and divide it by 2, and you will get the sigma average for test 3. So now you have find out the radius as well as the sigma average for all the 3 tests. After finding the radius and average test for each of these tests, we will draw a table for each of these tests. Each table will have 3 columns, in which the first column will be the angle column, second will be the x coordinate of the circle, which is equal to sigma average plus r times cos of theta, and third column will be the y coordinate of the circle, which is r times sine of theta. In angle column, you will write the angles in degrees starting from 0, then you will write 1. After that, you will select these two and drag it till 180 degree, because we are constructing only half of the Mohr circle. After that, you will select the x coordinate of the first angle, and you will write the equal sign, and then you will select the sigma average for the test first, which is 200. Then you will press on your keyboard F4. This F4 will introduce a dollar sign. This dollar sign is actually used to fix a reference to a given cell so that it remains unchanged no matter where the formula moves. After that, you will write the plus sign and select the radius for the test first, which is 85. Then again you will press F4 to introduce the dollar sign. Then you will write the multiplication sign, then write cos, and then start the bracket, write the radians, because the given angles are in degrees and we have to change them in radians. Then you will select the first angle, which is 0 degree. So this angle has a column row number of B12, so write B12 and then close the bracket and press enter, and you will get the x coordinate for the test first. Similarly, to get the y coordinate, you will select the y coordinate of the first angle and then at equal sign, select the radius for the test first, press F4, then multiplication sign, then sine, then start the bracket, write radians, select the first angle which has a row number of B12, or you can click on 0, then you will close the bracket and press enter, and you will get the y coordinate for the first angle. To get the x and y coordinates for rest of the angles, you will select these two and then drag it till 180 degree, and Excel will automatically calculate the x and y coordinate for rest of the angles. Similar procedure you have to follow for the test 2, that is, you will write the angles from 0 to 180 degree. Then to get the x coordinate, you will select the first row, then write equal sign, select the sigma average for the first test, which is 370, press F4 sign, then plus, then select the radius for the test 2, which is 130, again press F4 sign, then multiplication sign, and then write cos, then write bracket, radians, and select the first angle, which is 0 degree. This has the row number of F12, so write F12, close the bracket and press enter, and you will get the x coordinate for the first angle for the test 2. Same procedure for y coordinate, write equal sign, then select the radius of the test 2, press F4, then multiplication sign, write sine, then radians, then select the first angle, which is 0 or F12, then close the bracket and press enter, and you will get the y coordinate for first angle for test 2. Then to get the values for the other angles, select these two and drag it till 180 degree, and you will get the x and y coordinates for rest of the angles. Same procedure will be followed for test 3. That is, you will write 0, then 1, then select these two and drag it till 180 degree to get the angles. Then y coordinate, you will select the first row, write equal sign, select sigma average for test 3, then press F4 on your keyboard, then plus sign, then you will select the radius for test 3, again press F4, then multiplication sign, write cos, then radians, then select the first angle whose row number is J12, so write J12, close the bracket and press enter, and you will get the x coordinate for first angle for test 3. Similarly, y coordinate, select the y coordinate for the first angle, then equal sign, select the radius for the test 3, then press F4, then multiplication sign, write sine, then bracket, radians, then select the first angle for test 3, which is 0 degree, or it has a row number of J12, then close the bracket and press enter, and you will get the y coordinate for test 3. Then to calculate the values for other angles, select x and y coordinate for the first angle and drag it till the 180 degree, and you will get the x and y coordinate for rest of the angles. After getting the x and the y coordinate, now we will plot the Mohr circle. To plot the Mohr circle, you will click on the insert, then you will go to the charts and then select scatter with smooth lines. Then you will click on the chart area and select data. Then for the first one, you will click on the add button, and for the series name you will write the test first. Then you have to select the x coordinates for the test first, so you will select from the first, that is angle 0, till the last, which is 180 degree. After that, you will select the y values for the first test. And then click OK, and you will get the chart, that is the Mohr circle for the first test. Then you will delete this chart title and press on this plus button and click the axis titles. For horizontal axis, you will write the normal stress, in kilopascals, and for the vertical axis you will write the shear stress in kilopascal. So this gives us the Mohr circle for the first test. Now we can add, that is draw the Mohr circle for the other two tests. Again, you will click on the chart and then click on select data, and then press the add button and select for the series name, write test 2. Then you will select the x coordinate values for the second test. First you will move this chart to here. Okay, then click on this select data, then add button, write test 2. Then you will select the x coordinate values for the test 2. After that you will select the y coordinate values for the test 2. And click OK. Similarly, you can add the data for the test 3. To draw the Mohr circle for test 3, write add, and then for series write test 3. Select the x coordinate values for the test 3. Then select the y coordinate values for test 3. And click on OK button. Then press OK, and you can see that we have drawn the Mohr circle for the 3 test. You can change the size for this chart to see the Mohr circles clearly. After that, we will make some modifications to this chart. First, you will click on the horizontal axis and you will change the units, that is major units will be 100 and minor units will be 10. You can make the tick marks visible for major type as the cross and minor type as inside to see the values, and you can also change the color from gray to black. Okay, and you can also change the thickness. Similarly, you will select the y-axis, change its color to black and thickness to 1 point, and you can also change its unit. Major will be 20 and minor let it be 4. Make the tick marks visible for major type as cross and minor type as inside. Okay, so this gives us the Mohr circle for the 3 tests. After getting the Mohr circle, it's time to draw the failure envelope. Failure envelope is actually a line which is tangent to these 3 given circles. So first we will draw roughly a tangent to these given circles. To draw the tangent, you will click on the insert button and then shapes, and you will select a line, and then you will draw the tangent approximately. Okay, so we can see this is the tangent which touches the these 3 given circles at 1 point. So we can roughly see that the coordinate for this tangent, that is the point where it touches the vertical axis, it is like 0, 34, and point where it touches the third circle, it is somewhere between that is the x coordinate is 540 and the y coordinate is 182. So these are the coordinates of the tangent which touches these 3 circles. So you will delete this line and then you will write the coordinates, that is 0 and 34, which is the coordinate of the first point, and second point is 540 and 182. So these are the coordinates of the tangent. These are the approximate coordinates. You can change them. So to draw the failure envelope, again you will click on the chart area and then select data, and then click on the add button, and this time for series name you will write the failure envelope. For x coordinate you will select these 0 and 540, and y coordinates you will select these 34 and 182, and then click on the OK button, and you can see that we now have a failure envelope which is touching these three circles. Okay, so you can accordingly change the failure envelope if you find out that it is not touching these circles. Like if I write for 182, 178 and then press enter, I can see that failure envelope moving. Okay, in my case the coordinate for this failure envelope is, that is the second coordinate is 182, y coordinate. After getting the failure envelope, we can also get the equation for this failure envelope to find the cohesion and the angle of friction. So first you will click on the select plus button, and then you will select the trend line. Okay, and for the trend line you will click on the failure envelope, and then you will double click on this failure envelope, and you will click on display equation on chart, and you can see that we now have the equation that is for this failure envelope. From this equation we will get the cohesion and the angle of the friction. After getting the equation of the failure envelope to these three Mohr circles, we can find the value of the effective cohesion as well as the effective friction angle for this soil. So our trend line equation is 0.2741 times x plus 34. Effective cohesion or cohesion, this is the intercept of the failure envelope with the vertical axis. In our case we can see that the vertical axis and this failure envelope intersects at 34. It means the cohesion is equal to 34, and this friction angle, this is the slope of the failure envelope, so in this case it is equal to 15.33 degrees. So value of cohesion is equal to intercept of the failure envelope, which is 34 kilopascal, and friction angle, this is the slope of the failure envelope, which is tan inverse times 0.2741, which is equal to 15.33 degrees. So this gives us the value of the cohesion and friction angle for this soil. Now in part B we have to find the shear stress in the middle of the clay layer. To find the shear strength, we will first find the effective stress in the middle of the clay layer. This is given as sigma prime is equal to gamma saturated minus gamma W times H. So gamma saturated for the soil is 19 and gamma W is 9.81. We have to find effective stress in the middle of the clay layer. Clay layer has a height of 8 meters, so middle point will be 4 meter. So this gives us the value of sigma prime equal to 36.76 kilopascal. So shear strength in the middle of the clay layer is given as tau is equal to C prime plus sigma prime times tan of phi prime. Putting values of C prime, sigma prime and phi prime, we get the value of shear strength in the middle of the clay layer equal to 44.1 kilopascal. So this is how you can plot the Mohr circle for consolidated undrained triaxial test of soil in Excel. I hope you guys enjoyed this video and learned something new from this video. You can subscribe to my channel to stay connected and also share my videos with your friends. Thanks for watching, and I will see you in the next video.